What? Would you like to go with us in a long trip and deep inside an audio file and image file till the binary, bits 0 and 1? What we will do in this video, we will learn how to put an image file inside an audio file. How we will do that, we will break down the image file, PNG file or JPG file, doesn't matter. We will break down till we get the bits, the binary. Then we will add the binary files inside of an audio file. You will see it's just simple as you heard. If you don't know anything, no problem, just copy and paste from what I do. So you will get perfect hiding place to hide anything you want. It is not just for JPG file, it's for anything. You can hide audio file inside image file, or you can hide image file inside an audio file. What we will do in the first step, we will learn the theory, how it works, then we go and write together in a script. In this script, we get the smallest part of a file, such as a bit, a binary, and then we do other stuff. So let's go and start. Okay, let's go guys. We will see how can we hide an image file inside an audio file. And then we will extract the image file from an audio file. So first we will see how we can bring the binary, how we can break it down. Okay, as I said, we will break down an audio file to frames, and each frames have a lot of symbols. And inside of symbols, we have the binary. We will see in the scripting very clear how it works. Well, we also saw how we could measure an audio file with a binary, because each frames have symbols, and inside of symbols we have data of binary. So that's not very complicated. And after we broke down a data file of an audio file, then it's time to break down an image file. In this picture, we see a clear data. If you put a binary of an image, you will see the image. It's possible you can see image from his data. You can see here we have a lot of pixels. In the inside of the pixels, we have RGB. It means 3 color: red, green, and blue. And each color have one price, and that price will be changed to binary, and then it will create our data. So first we will break down the data of audio file, then we will break down an image file. If we go closer to this picture, we will see this picture created from a lot of pixels, and each pixel created by RGB, red, green, and blue. Each pixel is the result of mixing 3 colors: red, green, and blue. And here each color have a level. For example, 144 for red, and 141 for green, and 81 for blue. Then we can measure this binary like this: 1 0 0 1 0 0 0. This is the price of 144, and this binary is the price of this color, and this binary the price of this color. We will break down all the image as binary like this, and then we will put each binary one after one inside of a new audio file, and we will mix with the binary of audio file. Then we have a complete audio file, and nobody knows inside we have an image file. So this was the theory. I don't like to talk a lot, just we go ahead and directly we will start our scripting and see what we could do. So now we will work over this JPG file. This is an image file. As you see, we have a beautiful chicken here. And we have an audio file here. If you like to listen to this music, you can listen before we run our operation over this audio file. You can listen to it. And what we will do, we will take this picture and we put inside of this audio file. And still, you will see the audio file will work correctly and nice without any effect. And then we will delete this image file, and then we will bring the image file out of this audio file. So we start our script. What we're gonna do, we import the wave. This is a very important library in Python. We will use the wave to break down the audio file with it. And then we will write our first function, and this function will hide image inside an audio file. And this function, we need an audio file, we need an image file, and we need a name for the output. And then what we will do, we will directly open our audio file with wave library as read binary function. And then we have here the frame. What is the frame? I told you, as in the theory lesson, you saw the frame. The frame is the data inside of the audio file. We will use a binary because the binary function makes the data changeable. We can change anything on it, and we can remove, add, or other things. And also we have an audio, and we will use the read frames function to get the frames inside of audio file, the data. And for that, we need to get n frames. This will show us the total data inside of audio file. For better understanding, we will see how it works in another script. We will import the wave because we need it to open the audio file. So we will see what is inside of frame. We will print the frames. Then we'll run the script. We see all the data inside of the image. This is the data. We see with hex. This is the data of image, and it wrote by hex. So right now we have our audio data inside of the frame. We can use it. And then what we will do now we will open the image file with open function. We will open our image at read binary function, and then we will save image data with image read, EMG read that we have as EMG file, our image inside AMG, and then we use read function and then save it to image data. And we will see also this one, how it works. So we come here, paste it here. Okay, then what we will do, we will come here and we put our image.jpg. Okay, now we have our data inside of image data, and then we will print what is inside. What is inside? Image data. As you see, same thing as we saw before, previous data from audio. Now we can see it's the same thing data we have also in image. And we have our data of image here and data of audio here. And this variable frames and image data. And then we go ahead. We need the size of image, because we have to know how much data we will insert of the audio file to later bring it back. We will measure it by len function, and we put image data. It will give us the size of image. To make sure, we will go and see. We will see all the part of code like this. It's very simple and clear. And then we'll print the size. And now we see this is our size. This is the size of image. What we have. Our pictures have a bit high quality. That's why we have here a bit bigger size. So we go ahead. We have the size in decimal data type. But we need the size of data as a binary, because we have to put size and data together inside of audio file. That's why we need the size data as binary. We cannot insert the decimal file. So we will change it to binary. With what? With 2 bytes. We use this function. We use this function to get a binary, to get the bytes of that decimal file. So we will see this one also. We got to see this one also. Size bytes. Then we have here. Yeah, this is the binary. But we see the hex. Actually, this is the binary. We see as hex. And then we go ahead, and then we have our data. What is data? The size of bytes plus image data. We put the size and image data together, because we will put these two together inside the frames. And then we change the data to bits. We have changed image. We got the data inside of image data. Then we have the size of image with decimal data type, and then we change it to binary. But this binary is bytes, which a byte is 8-bit, but we need all 2 bits. For better understanding what is a byte, this is what we see. This is 1 byte, which created from 8-bit. 4 bits. We have 8 bits here. It creates 1 byte. It means 1 octet. And so we call for the last bit of this byte least significant bit. It means about this bit, it doesn't matter if you change to 1 or 0 the file. It does not make a lot of effect on the file. But this one, we call for this most significant bit. It means if you change this one, it means you change a big price in that file. It affects a lot. So we don't use this one, and we use this one in audio file. Let me say to you, for example, this is the binary file of image. You will get the first one, and you will put the last bit of audio file. And we will repeat again, and then we go ahead and fill, and then we will have all bits of image file inside of audio file, and that's voila. So we have the bits here. What the bits will do, this is the data. The data, it's bytes, but we will change it to bits. How? We'll change it to bit with format function, and this will change all bytes to bits, and it will save inside of this variable. And what's it join for? We will see that one also. No worries. We'll go here. We'll just print here. We'll print a bit. Now you see all the data changed to bits. We have 0, 1, 0, 1, 0, 1. If we can do this also. Now we don't like to use that one because that one's a bit complicated. So if you don't use the join function, it will be like this. It's a string file. We have still its bytes, but we want to join them with nothing. We will join them with nothing. We will join them. We'll use the join function. How? Like this. Join. And then we have our. This is our data inside of image file. We will put each single bit inside of an audio file, like 0, 1, go on until end, until it will finish. So we go ahead and we will see in this line code we have here a condition. What is condition for? We will check if the bits bigger than the frames. It means if the picture data is bigger than the audio data, then we will print out an error to understand what is the problem. Sometimes if you try to put a big image inside of a small audio, then it's not possible. It will crop your audio file. So this is the most important part of our script code. What we will do here, we will insert all of image data. It means bits inside of audio file. How we will run a loop in the range of image data. How much big is the image data, that much this loop will run and turn back. So we have here the frame I. What is the frame I? The first data inside of audio file. And what we will do with this data, first of all, we will run an operation with 254. This operation will change the last bit to 0. Why? Because if we come here and we will see what is the price of 254 in binary, it is very clear. We can see here that we have 1 byte, that the last bit is 0. Why? Because if we do AND, for example, I have, this is the first data inside of audio file. I have, let me add some 1, and this is the price of 254. If we run AND operation, what it will change. So AND, if you know the operations about binary, you will understand how it works. So in this example, 0 and 1, it will become 0. This one and this one will become 1 because both we have 1. The result will be 1, and this one will be 0. This one will become 1, and so on for these two, and these two we have 2 black zeros. And for this one, because here is 0, so it will change the price of that to 0. So we have the last bit 0, but others it won't change because we had run the AND operation, and this is the result of AND operation. Why we need to do that? Because we want to change the last bit to 0, each last bit in audio file. So that's why we will run first the AND operation over each single data inside of frame to change the last bit to 0. Then what we will do, we will make another operation, OR operation, with what binary inside of image files. Bit 1, as you saw the data of image file, we had 10, 10, 10, that was bits. We will run here the OR operation. What is the OR operation? So well, this is the result of AND operation, and now we have run the OR operation with a binary of with the bits that we got from image. If one of them is 1, the result will become 1. This or this doesn't matter. One of them is 1, and this one or this one will become what? 1, because we have 1 here. It doesn't matter. Or this one, and so on. We have here 1, and these two also will become 1. But if we have a data like this, like 0, 0, and up also 0, so will become 0. This is AND operation. But why we do OR? Because we will change the last bit with OR. So what we have, for example, this is the result of AND operation with 254. We will run the OR operation, so it will change the last to 1 if it is 1. If it's 1, if it's not 1, it will remain 0 for all data. So we go on, we have here all data inserted inside of a frame, and now the time to export our new audio file. We will open a new audio file with wave.open, and we will add here output that we will see later. We will give the name of output file inside of our function, and then we use the write binary function for these. And this one, I will tell you simply, it's just get the frame. It's just set up the setting of the old audio to new audio. It will make the new audio as same as last audio, because an audio file have some setting that we need to set up on the new audio file. So with this function, we use our last audio file to get the setting from that and use to our new audio file. And then just we need to export with write frames. And we use our frames. We had here our frames that we already inserted all image data inside, and then we use it for writing frames to new audio file. As simple you'll see. And then we need to close both audio file new one and old one. And this is what we see here all about hiding image inside. We will go and see how it does. We'll copy that and paste here. First we need to do something. Import wave. And then we need to fix all these. We need to bring it with that back because it was inside the function. Now it's not inside the function. We want to see it without any function. So we go here, and so we do it like this. And for this one also, we will save it. And what we'll do, and what we need to do, because it's not outside of function, we need to give here the audio file. We'll put audio. That's a wave. and here we need to give it our image file. Yes, we have the image.jpg saved here. Now we see here audio wave and image.jpg. So we can here, we can see here, we can come here and we save it, and then we go into run it. Right here, we have here one error that it makes sense. We need to change the name of audio.out, audio.out, audio/out.wave. Control A and run. We run the file, it's okay, everything is okay. So now we see here we have here audio.wave.output, our output here. We will listen to it. This is our audio file that we saw, and magically we have here inside our image. Now we don't need our image. We will delete our image. We will go write our script to bring out image from inside of this audio file. How we will do that? So simply we go to our Sublime Text and we come here to scripting and we will write here a new function, and in this function we need the name of audio file that we have added inside an image file, this image, this audio file. So then we have here the name of output of our new image file that comes out of this audio file. So here we will open our audio, simply as the last time, simply as previous example on the hiding function. Now we have also here we will open it, write binary, and then we get the frames. It means the data of the audio file, and then we have the bits. What the bits? So we have the binary, we have the frames here. The frames is bytes. We need to change the bits. We have here the bits, string, frame, and. Why we do frame and one? We run operation and over frame and one, because if we check here, if we come here, if we print when format 108b. Now we can go here, and there we will see, we run our test script. We see this is the price of when in binary. The last bit is on, is 1. If we run operation 1 with each single of frames, we will get the last bit. We will understand the last bit is on or off inside of the frame. I will change it to string because we need string for frame in the frames, because this is a loop, comprehension loop. And why inside of a loop? Because we need to run the loop over all frames in the audio file, not just when. We need all data. We will save it to the bit, and now we have all image files, image data inside of bits. And we need to sort the data in the bytes to octets, because in an image file we cannot do that. We have to change it to first it's in the bits. We will sort it to the bytes, and then we will change that to decimal, and then we will insert to new image. So how? We will use the same thing, byte array. It's a customized. It makes customizable the data. We use this one. This is make sort I to I plus 8. It will make 8 steps. 8 steps. It means it make bytes. It make bytes in base 2. And then we have here our loop, because we need to do over all data. And then our loop will run from 0 until the lane bits. The lane bits, it means the size of bits. How much is that? And then about 8 steps. It steps by step 8 and 8. Now if we go to test, and we will see how is this and what's the differentiation between this 8 bytes and data. And then we import here the wave. And then we will put our audio.out and for audio file we will add here the audio file that we got here. Look, we see here we have a file audio out. Okay, we need that file. So and also we will go print. First we need to print the bits. Yeah, as you see we have the data here. Bits, all bits, 0. This comes out of the last bit. LSB, we say least significant bit. It comes out from the audio file, the last bit. All last bit of audio files, it's here right now, inside of bits, but we need to sort it. And then we will print what? And then we will print the bytes. We will change how it looks now. Now we see here we have clear data here, as we had before. Now we can just export this to a new image file. So we go ahead. We have the byte here, and then we have the size. What was the size? If you remember, here we can see here, yeah, size byte plus image data. We have image data and size bytes. Like here, if we come here, unfortunately we cannot see the first data inside of this image. For example, the first bytes data we have inserted to audio file is the size. We have to separate them right now. We use what from bytes? We use this function byte data until index 4. This is the size of image. We will see here. We come here, and then instead of printing all bytes data, we'll print what? Just this one. Yeah, you see here, this was the first data that we extracted from audio, and this is the size we have extracted. And we don't need to insert this to image file because this is the size. We don't go very deep to that because we want to keep them simple. And then we go ahead. We have here the size, we have here data of image and image data, and then here we have the size, and then we have image data. Image data, it means after the index 4 is image data. Before index 4 was the size of image, and after 4, index 4 is the size of image. That's why we're making here variable image data. We will add this one from 4 to 4 and plus size that how much our image is. And then we go ahead, and this is the important piece of our scripting. So with open image, we will open a new image as write binary as image, and then we use write function to write image data inside of our image file. This is the last step. Then we will close the audio file. So in this part, we have one function for hiding image inside an audio file, and then we have other function to extracting file. But if we run the script, so the script will be confused if we didn't make it clear. What we need another variable. Why? Because we have to ask from user to choose between encryption and decryption or exit. He can choose. He want to encrypt or decrypt. It means he want to hide or he want to extract. And then we have here a condition. We will check if the choice variable is equal to 1. It means it's encryption. The user wants encryption. So what we need to input more from user. What to import? We need audio file, and we need the image file that user want. And then we will call the function hide image function. Then we will give the audio file that we got from user, and then we give the let me make it a bit bigger to understand clear, because we add here the audio file and then image file here that we got from user, and also we will write output file here, the name of output file. So this was for the hiding function, and we go ahead and we write another condition. If the choice function was equal to 2, then we will get an audio file, the encrypted audio file. That audio file, that user have added an image inside, and then we will call the function. We will use the audio file, what we will give the name of image file for output, for extract, and otherwise it will exit the file if you choose 3. So and we have else. This means it will print that you have choose 1. You didn't choose 1, 2, 3. You have to choose 1, 2, 3, and this is perfect. So now our script is complete, and we will save it. So we will now we go and see how it works. So we'll go to our terminal, and we will see first our files. We have here files. We have before we have encrypted. Before we have added our image file inside of the audio file. We got a new audio file that here, and then we delete the image file. Now we want to bring the image out from this file. How? We need to run our script. Payton script.py, and now it asks from user. We have already done decryption. We want to decrypt decryption too, and then we give it the audio file. Which one? This audio file. How? We just write the name audio and run out wave. So we will wait. It will do his work. Voila. Now we have our image here. If you can believe or not, we have done it. We just brought out our image from an audio file. And as you can see, we have our clear data without any noise, so the quality is perfect. As you see, we don't have any small change in the picture. If you like this kind of video, like and subscribe. Then I will see you in the next video with a new surprise. Bye bye.